Hello and good morning. This video is responding to a question that was left on one of my videos concerning bulge height. So the bulge height, or the Sagitta, is computed. It can't be physically measured, at least that I'm aware of. So let's say you have a point on the Earth's surface here at A and a point on the Earth's surface here at B, and you drew a straight line going through. That would be your chord distance or chord length. And then right into the middle here, from the chord to the surface of the Earth, would be the Sagitta, or bulge height. And so based on the information that we have, we can compute what the bulge height would actually be. So let's get into that. So let's start plugging in some of the things that we were given here. The person who asked the question gave us a 10-mile distance. So from point A to point B along the Earth's surface here was 10 miles. We have a radius here and a radius here. We know that this is at an average radius, right? 39, 59. This is 39, 59. And the way that we would get an average radius is that would be taken from 2 points on the equator and 1 point on either pole, depending on what hemisphere you're in. And so this would also be the radius plus this little bit. So it's going to be 39, 59, plus, we'll call it h, plus h, right? And so the first thing I want to do is I want to create a relationship to get this angle here that we're going to call theta. So I have this distance along the surface of the Earth here of 10 miles. So that's going to go here, 10 miles. And that is out of the entire circumference of the circle, which is going to be 2 times pi times our radius. And that's going to have a direct relationship and proportional to our angle that we're trying to find out of the entire 360 degrees, because this angle is going to be given to us in degrees. You could do this in radians as well, but most people think in terms of degrees. So let's solve this and get our angle. So I'm going to multiply it this way, and that's going to be 3,600. Now I'm going to work out this. 2 times pi times 3959 is going to be 24,875,130,631. And then we're going to divide that. So 24,875.130,631. And so that's my angle theta. So I'm going to erase all this and put my angle here. And I'll check my work real quick to make sure. 0.14722,858. Next thing I want to do is figure out where my right angle is. My right angle is here, which makes this now my adjacent side of my triangle, and this over here the hypotenuse of my triangle. And so what I want to do is I want to get half of this angle. So we'll call it theta subset 1, and that's going to be 0.07. So we'll go 0.072361429. And so what I want to do now is set this up with what pieces of the triangle I have. And I'm going to be using the cosine. So now I have everything I need to solve this. And so it's just a matter of using a little bit of algebra. I'll be using the cosine function because of the sides of the triangle that I have. I have my adjacent side and I have my hypotenuse. I have half the angle. So it's going to be cosine half that angle is going to equal my adjacent side divided by my hypotenuse. So I want to get x by itself, so it's just a little bit of algebra. These two cancel out, x is by itself, and I will multiply both sides. Same thing I did over here, I'm going to do over here. So I'll take this angle, I'll hit the cosine button, multiply by 3959. Okay, so here is half my angle. I'm going to hit the cosine button. And now I'm going to multiply that by 39.59. And we'll write that down. So this is what I had when I solved for this side of the triangle. Now I know that the entire radius over here is going to be 39.59. So if I take 39.59 and minus this, I'll get what this leftover piece actually is. So I'll just take 39.59, I'll roll that up and then minus that out. So that's my measurement in miles. So this is our leftover little piece in miles. So let's turn that into inches. And then now we'll divide by 12 to get into feet. So that's our answer. Our answer is that H, this little piece here, so H equals 16.67 feet. I computed H. I didn't physically measure it. We didn't dig a hole from A to B and then a hole at the top here and then measure down with a tape measure. We didn't do that. We computed it. And so we can do that knowing the properties of circles and triangles and having some measurements. We just usually need a few measurements and then we can compute the rest. And so I wanted to show you a quick example. Let's hypothesize that you bought the adjacent property to yours and it's got this sort of irregular shape to it. And you want to kind of go out there and see what the area of this irregular shape is. You don't really have much to work on. You do have a 300-foot rag tape, a couple of nails, and some wooden lath. And so you set a nail and a lath over here, or just a nail or whatever, and then you pull your 300-foot rag tape over here, you set one over here, and you've got 300 feet. So what you would do is you would come off this point 100 feet, throw a nail in the ground, turn a 90-degree angle to the right, and you'd put a point here, and you'd do the same thing to the left. And so this point here is 100 feet. You'd come off another 100 feet, so now you're 200 feet from the starting point, and you'd point a point here, and you would do the same thing over here, and you do the same thing over here. Then what you would do is you would measure these distances here. And so we'll just say that this is 50 feet, this is 40 feet, this is 55 feet, this is 45 feet, this over here is 60 feet, and this over here is 55 feet. And so what you would do is you would now tabulate this into a table. So now we can put these in a table. We can say that everything to the right that we measured is a plus, everything to the left that we measured is a minus. So we would say, okay, we came over 100 feet, write that down, 100. We had a plus 50, we came over 100. We had a minus 40. We came over 200. We had a plus 55, 200. We had a minus 45. We came over 300. We had a plus 60. We had a minus 55. Now you could get really granular with this. Basically right now, if you think about it, we used bowling balls as a unit of measure. You could get real granular. You could use golf balls, basically. You could come out to basically here and then tape up this way and tape this way. And you could really get granular with this measurement. And so now that you have this, which is essentially the state plane coordinate system, these would be basically your northings and these would be your eastings. What we can do now is we can label where we intersect with the outside perimeter. So now if we rotate this 90 degrees clockwise, we essentially have our northings and we have our eastings. And so if we went around and we labeled all these points, all these nails that we put in the ground, and then connected them, let's say this is A, B, C, D, E, F. And we connected these, let's say I connected A to B, B to C, C to D, D to E, E to F, and F to A. Now, obviously, like I said, I can get a lot more granular with this. This is just a rough idea. Let's say I pulled up just 10 feet out and I had a point here and then I had a point here. You can see that I can get a really close to what this measurement is. Now, I didn't physically, right? Now I have a perimeter. I can measure this perimeter, which means I can get the area. I didn't actually go out and physically measure from A to B. But if I can get one right triangle out of this, I can compute the rest based off of that.